Next, question number 7. Just 1 second, 47. 45.2. Okay. The heat of neutralization of the sodium hydroxide with HCl is 57.3 kilojoules, and with HCN it is 12.1 kilojoules. The heat of ionization of the HCN is. So therefore, this it is also like a previous problem. That means whenever if they ask the heat of ionization of the weak acid or weak base, apply the standard formula like this: heat of ionization. Heat of ionization is heat liberated when weak acid or weak base participates. Minus heat of neutralization. Neutralization of strong acid, strong base. Heat liberated when the weak acid or weak base participates is given as 12.1 minus of minus 57.3. 57.3. Therefore, the answer is 45.2 kilojoules per mole. Therefore, the answer is B. Okay. Question is the theory part అయితే మళ్ళీ దీన్ని చూసే పనిలే, డైరెక్ట్ చేసేయచ్చు అట్లా. Question number 8. Okay, sir. Okay. Okay. Question number 8. Del X is given as hydration energy minus lattice energy for a salt. Del X is found to be 500 kilocalories per mole. Therefore, on increasing the temperature, its a solution on increasing temperature, what is the solubility, how it changes? Increases, decreases, remains same, increases. Therefore, usually if the sum of the hydration energy and lattice energy is positive, therefore we can say that the dissolution process is endothermic. Since the dissolution process is endothermic, therefore with rise of temperature the dissolution process always increases. Hence, answer is increases. Answer is A. Correct. Answer is A. Next, question number 9. 4 grams of NaOH is dissolved in water Next, 4 grams of HCl is added into the same solution. Therefore, the heat generated in kilocalories per mole is. Next, here in the experiment they have taken 4 grams of the NaOH, 4 grams of the NaOH. Therefore, convert these 4 grams of NaOH into equivalents. 4 by 40 equivalents is 0.1. Next, into the same solution now they are adding the acid. Here the added acid is a strong acid HCl. Next, the amount of the HCl added into the solution is given as 4 grams. Convert this 4 grams also into equivalents. For HCl, the gram equivalent weight is 36.5. 36.5. So therefore, here we will get slightly more than 0.1. Slightly more than 0.1. Next, represent the neutralization reaction between HCl and NaOH. The neutralization reaction is NaCl plus H2O. According to the principle of heat of neutralization, X equivalents of the first reactant always combines with X equivalents of the second reactant. Here, one reactant is taken in lesser proportion, another one is taken in more proportion. Therefore, the reactant whose equivalents are lesser will completely participates. Here, which is lesser? Sodium hydroxide. How many equivalents of sodium hydroxide are taken? 0.1 equivalent. Therefore, sodium hydroxide equivalents are 0.1. Hence, equivalents of HCl required in this reaction should also be 0.1. Hence, the total amount of the sodium hydroxide will participate in the reaction. Therefore, proportionate amount of the heat will be liberated. Next, according to the principle of equivalence, whenever if one equivalent participates, the amount of heat liberated is 13.7 kilocalories. If 0.1 equivalent participates, how many? How much? 10 times less, 1.37 kilocalories. The answer is 1.37 kilocalories. So, in which option 1.37 kilocalories is given? Answer B. Answer B. Okay, sir. No, ఇది అయిపోయింది. ఇది ముందు నేను పేపర్ మీద నాకు ఇస్తే పేపర్ మీద కానీ రాసుకుంటే లెస్ టైంలో ఎక్కువ అయిపోతాయి, మీకు డబ్బులు మిగులుతాయి. ఇది ఊరికి డబ్బులు వేస్ట్ కదా రికార్డింగ్ అంతా, ఎందుకు డబ్బులు వేస్ట్ చేయటం. అలాగే నెక్స్ట్ క్వశ్చన్ నంబర్ 10. In which of the following reactions the heat liberated is known as standard heat of formation of CO2? So, for the standard formation reaction, what we have to do is observe the number of moles shown on the product side. On the product side always 1 mole must be shown. Next, that product should be in its standard state. Next, say for the formation of the CO2, the number of moles of the CO2 on the product side must be 1. And the physical state of the CO2 should be gaseous state. Next, for the formation of 1 mole of the CO2, we need 1 mole of the graphite. We need 1 mole of the graphite. Next, we need 1 mole of the oxygen gas. So, the reaction in which 1 mole of the graphite combines with 1 mole of the oxygen to give 1 mole of the CO2 is the correct representation of the standard heat of formation of the CO2. So, in which option it was shown like that? You see, in C option, graphite plus O2 gives CO2 is given. Therefore, answer is C. Okay. Just wait. క్వశ్చన్స్ కొన్ని ఎర్రర్ ఉన్నాయి, ఇంక ఇప్పుడు రెక్టిఫై చేయలేము ఆ క్వశ్చన్లోనే ఎర్రర్స్ ఉన్నాయి. లేదు రాంగ్ ఉంది. ఓకే ఓకే, ఈ క్వశ్చన్ ఇది పెద్ద అంత పెద్ద ఇంకోసారి చెప్తాను, దీనికి అవసరం లేదు. వద్దు దీనికి అవసరం లేదు అంత మీరు చెప్పాల్సిన, నేను ఈ దీంట్లో మేనేజ్ చేసేస్తాను. దీనికి ఏం చేయాల్సిన ఇంకో దానికైతే చేద్దాం ఈసారి వచ్చిన, దీనికి అవసరం లేదు, ఇది చల్తా.